So what is the tapply function? Well, the tapply function is a type of apply function that is used to apply a function to all the values associated with a certain level of a factor variable. So basically, the tapply function is really useful for summarizing information for different groups of data. The tapply function takes the following arguments. It takes capital X, which is an object for which a split method exists. That probably doesn't mean much to you, but typically you want to give the tapply function something like a vector or a data.frame object. The next argument to tapply is the index argument, which is going to be a factor variable with the exact same length as x. This is the variable that is going to be used to split x into different groups. After the index argument is the fun argument, which is the function to be applied to each group of x after the split function is used. So once you split the x variable, then fun is going to be applied to each group of data. If your fun takes additional arguments, they can be passed to fun using the ... or ellipsis argument. There is a default argument which we're going to ignore. You can run $tapply in the console if you want more details. But the last argument that may be relevant is the simplify argument, which is a logical value indicating whether the result should be simplified to a scalar array. The default is true, otherwise the function will return a list. So we are going to use the tapply function to summarize chicken growth across different feed types. So we're going to use the chick weights dataset and the datasets package. The chick weights dataset is a data frame with 71 observations of 2 variables. The data provide the results of an experiment to measure and compare the effectiveness of various feed supplements on the growth rate of chickens. This data frame has 2 variables, weight, which is the chick's weight in grams, and feed, which is a factor variable indicating the feed type. So we're going to use the tapply function to compute the average chicken weight of the chickens receiving each feed type. So we use tapply here. We're going to apply the mean function to the weights associated with each level of the feed variable. So I'm actually pulling out the weight values from chick weights, and I'm actually going to be pulling out the feed variable from chick weights to supply to the index argument of tapply. So when I do that, I get a bunch of information here, and what is this telling us? It's telling us that the mean weight of the chicks in the casein group was 323.6 grams, of the horse bean groups was 160.2 grams, of the linseed group was 218.75 grams, and so on. If we wanted to do something more complicated, we can use the tapply function to compute a more complex summary of each group's weights using the summary function. So in this case, I'm going to once again extract the weights from chick weights and supply that as the x variable of tapply. I extract the feed variable of chick weights and supply that to the index argument of tapply. And then I'm going to apply to each group, after we split the data, the summary function. And so we can see that for the casein group, the minimum weight was 216 grams, the maximum weight was 404 grams, the median was 342. If we go down to the sunflower seed group, we see that its mean was 226 grams, its max was 423 grams, its median was 328 grams, etc.